Hi everyone, and welcome to day 4. I'm going to do something a little different this time. We're just going to try and do this blind, live, and see what happens. If I fail miserably, I will probably, just put up the same sort of video style I've been doing the last few days. But if you're seeing this, it means I didn't fail too miserably. So let's get into it. So we have day 4 here, and just gonna skim this. I'm gonna pause for a second and read it to not waste your time. You can of course read it on your own. Okay, so from what I understand, we're given some scratch cards, those little lottery ticket things that have various winning numbers on it. And then you're also given the numbers that you got, and we have to decide if it's a winning card. Basically, each match you get a point. But then it's like 2 points for the second match, 4, 8, 16, 32, 64, I imagine is kind of the math here. So let's just kind of get some stuff started here. So I like to just kind of take this, and I'm going to make something called December 4, and then ground truth.txt, and put that in there. And what we're going to do now is also make a December 4th underscore a.dart. And I usually just take something like one of my existing ones and pull it into here, grab in this file, if we can grab it. And we want to change this to December 4th. And then there's going to be one for December 4th.txt for our real input. That does not exist yet. And we'll make something called solve. So solve is going to take as usual, just a list of strings. Oops. And we'll just call it values, as I've been doing most of the time. And this isn't actually a void function. This will return likely an int. And then I'm just going to do return 0, just so we can kind of, not have any errors. And then I like to just actually run the program. This is just my process. Just make sure we actually get something back. Okay, so no errors. All right, so let's first of all take a look at what's in here. So I'm going to just make sure everything's good. We're going to just print values.first. And there we go, we got our card. So the first thing we need to do is parse this. And it's like sometimes there's double spaces. I guess it's just like based on if there's 1 digit or 2 digits. Does the actual card number matter? I don't think so. So what we can kind of do is, first of all, so let's just do, oops, in the wrong place. Let's go over here. And we'll just do, maybe we'll call it row in rows. I'll just rename this to rows. We're just going to make a random variable name and essentially go row.split on this. And then we want to go .last, and then we can even trim it if we want. And basically now, and I'll rename, I usually just kind of write random letters because I don't even know what to call this thing yet, but we'll just go, we'll do like, is the winning on the left? Figure out which numbers appear in the list of winning numbers. The first match, okay. 2 lists of numbers separate. The list of winning numbers and then the list of numbers you have. Okay, so we'll call these winning numbers, and that's essentially going to be, we'll take our D and we'll split on this, and then we'll just call it like my numbers, and this will be first and this will be last. And let's just make sure that these are coming out correctly. We'll just kind of do some printing here. Poor man's debugger. And let's just make sure we kind of see. Okay, cool. So we're getting 41 on that one, and then this should be 83. Yep. Okay, so far so good. Okay, so now we need to essentially actually get the numbers into here. So I think we could probably just use a regular expression for this to make it really easy. So let's do, so we have our winning numbers here. So we could actually just go regex, and I believe if we do an /d plus dot all matches on that input. Let's just see if that actually works. So we'll print winning numbers. Okay, so we are getting regexes back, which is good. winning numbers. So we actually want to parse those, but I think that's working. But let's just make sure. And it's dot, I guess we'd want to map through these and then convert back to a list. So this would be the match. I'll just call it M, and we would go M dot group 0. So let's see. Okay, cool. So we got 41, 48, 86, 17. Yep, looking good. So we basically want this exact same logic here. Probably a way we could break this into a reusable function. And we just want this to be the last part of this. And let's just print my numbers instead. We know winning numbers works. Cool. Okay. So now we can basically just go, it makes sense to, we'll go through my numbers for final num in my numbers. One thing we might want to do, oh no, these are, yeah, are these actually strings or integers at this point? Let's just find out. Print. I think they might still be strings. Num dot runtime. We can do runtime type just to see what kind of type it is. So they are strings. So actually what I'm going to do over here is actually do an int dot parse on each of these. Let's just make this a little bigger. Int dot parse m dot group. And we'll grab that there. So now we're getting ints back, which is good. That'll just be, you know, better for comparison purposes. Let's just make sure there's also no there's no trail, there's no leading zeros or anything, so we won't have a problem with that. Okay, so all we need to do now, I think, is if my number, or if winning numbers dot contains my number, not my numbers, but what contains num, then essentially we know we at least have one. So it's a doubling sort of situation. So let's first of all, at the start of this, just make an integer called win count, I guess. We'll say 0. And what we'll do is we'll just start by incrementing this, win count plus plus. And then at the very end, we can actually print out our win count. And let's just make sure that that's actually working. So we get 4, 2, 1, 0. Okay, in the above example, card 1 has 5 winning numbers. Interesting. Above example, card 1 has 5 winning numbers being this. And 8 numbers you have. Of these numbers, 4 of them are winning numbers. Okay, so we are getting that part right, which is good. Now we just have to figure out how to double this each time. So actually, I mean, there's probably a million ways we do this using like some kind of thing, but we could just have points. And we can, I'm going to do this because I'm kind of doing this live, so I'm not necessarily giving this the best thought. If points is equal to 0, then we'll just say points equals 1. We'll set it to 1. Otherwise, points times equals 2. Is that something we can do in Dart? I assume so. We can do in other languages. So let's see if these points seem to match up. Okay, 8 points, 2 points, 2 points, 1. 8, 2, 2, 1. Yep, okay, our math is good. And then what do? We add it together? I guess we do. So we have our points. So at the very end of this, we're going to have just a int called sum equals 0. Maybe we'll call it like total points. Total points equals 0. And what we'll do at the end of all of these is we'll just go and say total points plus equals points. And that'll get cleared out every time. And really what we want to do from this function is return total points. And then we should see our final answer being 13, which is what this says. Okay, cool. So now we're going to run this through into our lovely actual thing. Get my puzzle input. So I'm going to grab all this. And we're going to make one December 4th.txt. And of course I spelled txt wrong. It's a hard one. And I'm just gonna get rid of that trailing line, even though I don't think it matters. Just playing it safe. And where did we go? December 4A. So now I'm just gonna change our, oops, usually I like to have this code actually just down by my main function. And let's just do ground truth false. So now it should actually use that file, assuming I spelt everything right. And we got back this lovely number here. And we'll go over to here and we will paste it in. And luckily, we are correct. Okay, good. All right, continuing to part 2. Okay, part 2, I'm just going to take this in and read it, and then I'll give you the quick TLDR. All right, this one's a doozy. So everything's changed now. Instead of points, the way this kind of works now is anytime you win, so when you have matches, so we don't really care about this doubling of points sort of thing anymore. You actually, so in card 1, because it has 4 matching numbers, I actually win a copy of the next 4 cards. So that would like go into my inventory. Card 2, 3, 4, 5, like duplicates of those. And then in card 2, it's basically just going to be this massive recursive sort of function to, and ultimately it's just like how many cards have you won. In this case, in this sort of example 1, let's see, you end up with 1 instance of card 1, 2 of card 2, 4. So we just care about the instance of the cards. But we need to still know which cards they are because we have to reprocess them. Ultimately, I have 30 scratch cards. So I am going to, just because I feel like I'm going to waste everyone's time really like fidgeting with this, I am going to pause my recording and I'm going to try and figure this out, and then I'll walk you through the solution. All right, I'm back. I have a bit of a solution here. Okay, so what I decided to do is make this a little more object-oriented to just make it easier to kind of think about things and not worry about parsing data. So essentially I've made a card class here, and because this is just Dart and not Flutter, we're not going to conflict with the built-in Flutter card class by any means. And basically we're going to track the winning numbers, my numbers, and the amount of copies that exists. The copy will be 1 by default because even though it's not really like being copied, there's 1 instance of it. So as long as a card's been made, we know there's at least 1, so that's the default there. And then I just have a nice little getter function that I basically pulled from our part 1 that just put in the object instead. And it just loops through and gives you a count number. So we can just go .match count instead of having to rerun this logic anywhere. And then I have sort of like a factory or I guess a class function. No, not a class function, just a function that will essentially return a new instance of a card by adding in copies. And this is just something, it's good to do with Dart because you want to make your classes immutable. So I don't want to actually be updating my copies as I'm looping through things. Instead, I want to return a new instance of a card that just has the change. So this basically just returns, a copy of winning numbers, my numbers, and then it updates the copies by adding the current copies with whatever I pass into this, which we'll see in a little bit. And actually, this was something I was fiddling around with, a little recursive function, which ended up not being needed for this. So yeah, it's pretty basic once I got my head around it. Basically, what I want to do is, first of all, just construct those, what I'm calling the unique cards. So this is like the cards that are in my original set. And I'm just looping through them. This is no different than before, more or less, except we are just essentially creating a new card with those winning numbers that we've parsed and my numbers, and then setting copies to 1. We could technically omit this because the default is 1, so I will remove it there. And then we're just adding those. So now this is just a loop really to construct our data classes. Then right here, we just have total cards equaling 0, and that's going to be our count that's going to increment. And we're going to loop through this. Now I'm looping through this as a map so that I can get the index and the actual card, the index being the key of that entry, and card being the value. So it's just a nice way to auto increment a loop of a list. So what we want to do is just increment this number by every time we get through this, we are going to essentially update our total cards based on the copy. So the very first time this goes through, the very first loop, the very first card will only actually have 1 copy. So this will add 1. But then what we do after this is we look at we set a value called I, which is our current index plus 1. So basically the next card. And then we actually want to run this loop for starting at that number, but starting at the index, starting at this number, and then as long as we're less than the index plus the card.match count plus 1, and then we'll keep incrementing. And what we're going to do here is we're going to make a copy of the card. We're essentially going to take whatever card we are looped in right now. So this would be the next card in the deck. And we're going to make a new instance of a card by running that add copies function. And again, that basically just updates, sends a new instance of this class back with that updated number. And then we essentially are going to remove the original one that was in our unique cards list at whatever I we're at right now, and we are going to insert it. We're basically just replacing it so that the next time it goes to the loop and it finds something, the card copy will be different and it'll keep adding up. So that was basically my solution here. I originally was trying to do this recursively and realized that's not really necessary because we can just be mutating the data as we go. Now, if this challenge was a little more complicated where it would do stuff in reverse in a way, like if it would be like, oh, you got the card previously and the card later, I'd probably have to rethink this entirely. But because we are going through this in order, as long as we're looking ahead and then updating things in time before it actually gets to the next card, we are good to go. So that's kind of what we're doing here, and I was able to run it and get my source of truth, and then I ran it shortly after and did get the correct answer. So thanks for watching again, and we'll see you in the next one.